I believe in the notion, and I don't have a better word for it, maybe you do, or phrase for it, is of kind of a cognitive velocity. I sometimes will play with this. I'll read slowly, or I'll see where my default pace of reading is at a given time of day, and then I'll intentionally try and read a little bit faster while also trying to retain the knowledge I'm reading.
Right.
Like going to a restaurant for the first time, there are a number of new interactions. Right? There might be a host or a hostess. You sit down at these tables you've never sat at. Somebody asks you questions. You read it. Okay, maybe it's a QR code these days, but forever after you understand the process of going into a restaurant, doesn't matter what the genre of food happens to be or what city, sitting inside or outside, you can pretty much work it out. Sit at the counter, sit outside, sit at the table. There are a number of key action steps that I think pretty much translate to everywhere, unless you go to some super high-end thing or some super low-end thing where it's a buffet or whatever. You can start to fill in the blanks here. If I understand correctly, there's an action function that's learned from the knowledge and the experience.
Exactly.
And then where is that action function stored? Is it in one location in the brain, or is it kind of an emergent property of multiple brain areas?
So that you're right at the cusp here of where we are in neuroscience right now. We don't know the answer to that question. In the past, it had been thought that the cortex were like countries on that each part of the cortex was dedicated to one function, right? There's and interestingly, you record from the neurons, and it certainly looks that way, right? In other words, there's the visual cortex in the back, and there's a whole series of areas, and then there's the auditory cortex here in the middle, and then the prefrontal cortex for social interaction, and so it looked really clear cut that it's modular. And now what we're facing is we have a new way to record from neurons. Optically, we can record from tens of thousands, from dozens of areas simultaneously. And what we're discovering is that if you want to do any task, you're engaging not just the area that you might think has the input coming in, say, the visual system, but the visual system is getting input from the motor system. Mm-hmm. Right? In fact, there's more input coming from the motor system than from the eye. Real complex cognitive behaviors emerge. It's from those interactions. And now we have the tools for the first time to actually be able to see them in real time. But there are other things in sleep that we discovered having to do with traveling waves. There are circular traveling waves that go on during sleep, which is astonishing. Nobody ever really saw that before. They're called sleep spindles. Mm-hmm. They last, the waves last for about a second or two, and they travel, like I say, in a circle around the cortex. And it's known that these spindles are important for consolidating experiences you've had during the day into your long-term memory storage. Mm-hmm. So it's a very important function. And if you take out, it's the hippocampus that is replaying the experiences. It's a part of the brain that's very important for long-term memory. If you don't have a hippocampus, you can't learn new things. Mm-hmm. That's to say, you can't remember what you did yesterday, or for that matter, even an hour earlier. But the hippocampus plays back your experiences, causes the sleep spindles now to knead that into the cortex. And it's important you do that right, because you don't want to overwrite the existing knowledge you have. You just want to basically incorporate the new experience into your existing knowledge base in an efficient way that doesn't interfere with what you already know. So that's an example of a very important function that these traveling waves have.
As I recall, there are one or two things that one can do in order to ensure that one gets sufficient sleep spindles at night, and thereby incorporate this new knowledge. This was from the episode that we did with Gina Poe from UCLA, I believe, and others, including Matt Walker. My recollection is that the number one thing is to make sure you get enough sleep at night so you experience enough of these spindles.
Right.
And we're all familiar with the cognitive challenges, including memory challenges and learning challenges associated with lack of sleep, insufficient sleep. But the other was that there was some interesting relationship between daytime exercise and nighttime prevalence of sleep spindles. Are you familiar with that literature?
Yes. Oh, yes.
Yeah.
No, this is a fascinating literature, and it's all pointing in the same direction, which is that, we always neglect to appreciate the importance of sleep. I mean, obviously, you're refreshed when you wake up, but there's a lot of things happen. It's not that your brain turns off, it's that it goes into a completely different state. And memory consolidation is just one of those things that happens when you fall asleep. And of course, there's dreams and so forth. We don't fully appreciate or understand exactly how all the different sleep stages are work together. But exercise is a particularly important part of getting the motor system tuned up, and that it's thought that the REM, rapid eye movement sleep, may be involved in that. So that's yet another part of the sleep stages. You go back and forth between dream sleep and the slow wave sleep, back and forth during the night. And then when you wake up, you're in the REM stage, more and more REM. But that's all observation.
I believe in the notion, and I don't have a better word for it, maybe you do, or a phrase for it, is of kind of a cognitive velocity. I sometimes will play with this. I'll read slowly, or I'll see where my default pace of reading is at a given time of day, and then I'll intentionally try and read a little bit faster, while also trying to retain the knowledge I'm reading.
Right.
So I'm not just reading the words, I'm trying to absorb the information. And you can feel the energetic demand of that.
Oh, yes.
And then I'll play with it. I'll kind of back off a little bit. And then I'll go forward. And I try and find the sweet spot where I'm not reading at the pace that is reflexive, but just a little bit quicker while also trying to retain the information. And I learned this when I had a lot of catching up to do at one phase of my educational career. Fortunately, it was pretty early, and I was able to catch up on most things. Occasionally things slip through, and I have to go back and learn how to learn. And if I get anything wrong on the internet, they sure as heck point it out, and then we go back and learn. And guess what? I never forget that, because punishment, social punishment, is a great signal.
Yes.
So thank you all for keeping me learning. But I picked that up from my experience of trying to get good at things like skateboarding or soccer when I was younger. There's a certain thing that happens when skateboarding, that was my sport growing up, where it's actually easier to learn something going faster. Most kids try and learn how to ollie and kickflip standing in the living room on the carpet. That's the worst way to learn how to do it. It's all easier going a bit faster than you're comfortable. It's also the case that if you're not paying attention, you can get hurt. It's also the case that if you pay too much cognitive attention, you can't perform the motor movements.
Right.
So there's this sweet spot that eventually I was able to translate into an understanding of when I sit down to read a paper or a news article or even listen to a podcast, there's a pace of the person's voice, and then I'll adjust the rate of the audio where I have to engage cognitively, and I know I'm in a mode of retaining the information and learning. Whereas if I just go with my reflexive pace, it's rare that I'm in that perfect zone. So I point this out because perhaps it will be useful to people. I don't know if it's incorporated into your Learning How to Learn course, but I do think that there is something which I call kind of cognitive velocity, which is ideal for learning, versus kind of leisurely scrolling. And this is why I think that social media is detrimental. I think that we train our brain basically to be slow, passive, and multi-context cycling through. And unless something is very high salience, it kind of makes us kind of fat and lazy, forgive the language, but I'm going to be blunt here, fat and lazy cognitively, unless we make it a point to also engage learning.
Right.
And my guess is it's tapping into this mitochondrial system.
Very likely. That's one part of it. By the way, the way that you've adjusted the speed is very interesting, because it turns out that stress, everybody thinks, stress is bad, but no, it turns out stress that is transient, that is only for a limited amount of time, that you control, is good for you. It's good for your brain. It's good for your body. I run intervals on the beach, just the way that you do cognitive intervals when you're reading. In other words, I run like hell for about 10 seconds, and then I go to a jog and I run like hell for another 10 seconds, and it's pushing your body into that extra gear that helps the muscles. The muscles need to know that this is what they've got to put out, and that's where you gain muscle mass, not from just doing the same running pace every day.
Thanks for watching. If you found this information helpful, be sure to like, share, and subscribe for more health and wellness tips.